Our lesson for today is a little bit shorter than the last couple that we've looked at, and we're focusing on our interpretation of our results, recognizing the differences between a type 1 and a type 2 error uh, after we've come to our conclusions in a hypothesis test. So, we're going to use a metaphor that we've talked about already this year in the courtroom. And we've already said that the null hypothesis is like the presumption of innocence. You're innocent until proven guilty. And it's the job of the prosecuting attorney to present the evidence that the jury can ultimately make a decision if they feel that the evidence is strong enough to reject that presumption of innocence, that null hypothesis, and accept the alternative hypothesis that the defendant is guilty. Or if the defendant, there's not enough evidence to say that he or she committed the crime, the jury comes back and says that we find the defendant not guilty, meaning that they believe the null hypothesis is true, that the defendant is innocent. Again, you don't really come out and say that the defendant is innocent. So let's say that the wrong decision is made. Let's look at these two possible cases. Um, Choice one, we cannot rule out that the defendant is innocent, so he or she is set free without penalty. So that would mean that you believe that the null hypothesis is true, so they're found to be not guilty. Now that means if they really did commit the crime, then you have that free person, you have that criminal set free, and they're not being punished for that crime. Now that's a bad thing, but take a look at choice two. What if you believe that you do have enough evidence to convict the person and you find the defendant guilty? But really, unbeknownst to you, that person is actually innocent. Now you have the innocent person who is sitting in jail for a crime that he or she did not commit, and the actual criminal has still gone free. Okay, so you could argue that this case right here is actually more severe if you make a mistake in this second case because you have two things going wrong. Okay, it's thought of as being more serious. Okay, innocent person is sitting in jail, and the actual criminal um, is gone free, and nobody's really looking for that person. So that's important to keep in mind when we're looking at these hypothesis tests. Oftentimes you're going to find one of these errors to be more serious than the other in the circumstances of your problem. And that should be something that's considered when you're looking at your conclusion. What are those errors? What do they look like? If they if something was gone or something has gone wrong, um, are you willing to live with that type of an error? So in this case, here's our thought question. It says, which is generally more serious when getting the results of a medical diagnostic test? A false positive, which tells you you have the disease when you don't, or a false negative, which tells you you do not have the disease when you do. We talked about this a little bit right before this pandemic happened, and we were still in school, and we were saying that the most catastrophic cases are when you have a false negative where somebody goes to the doctor, they think that they might have this disease, but the test comes back negative. You don't have it. And therefore, they go home and they actually do have this disease and they're not pursuing any treatment for it. Okay, that seems to be the worst case scenario as opposed to a false positive where um, it comes back that you do have the disease, you start to perform some or another test or start to take some actions against it, and then you realize that no, you actually don't have the disease. It's a false positive. Um, the false negative seems to be more catastrophic. Now, the nice thing about that is that we saw that those probabilities were incredibly low typically for a false negative. But it's the same type of error analysis. If a mistake happens, okay, what are the consequences of that mistake? And that should be considered. So let's take a look at a case right here, kind of like what we just talked about. Null hypothesis is that you do not have the disease. Alternative hypothesis is that you do have the disease. So the test result comes back negative for the disease. The potential error would be that you have the disease, but you are told that you do not. This was a false negative. Choice 2, medical practitioner thinks you have the disease. The result comes back positive. However, you are healthy, but you're told that you have the disease. Your test was a false positive. Okay, so we talked about this false negative is typically thought of as being more consequential than the false positive. So that leads us into our two types of errors. Okay, type 1 and a type 2 error. We have this little chart here that kind of summarizes what's going on in each of these cases. But let's start pretty simple here. We have our two hypotheses, our null hypothesis and our alternative hypothesis. I think the best thing to remember when you're determining if it's a type 1 or a type 2 error, the number of the error refers to the hypothesis that is actually true, but the results of your test led you to the other one. So for example, let's say that you go through and you have a p-value of, let's say 0.03, which is obviously less than 0.05. So you reject the null, accept the alternative. You believe that the alternative hypothesis is true. The second hypothesis, you have a possibility of a type 1 error, because that would mean that you believe the second hypothesis is true. If the first one is actually true, okay, that is a type 1 error, where the null hypothesis is true, but you came back with a p-value that was less than 0.05, so you followed all the rules and you rejected that null hypothesis when it was actually true. Okay? That is a type 1 error. And a type 1 error, we talked about one error typically being less consequential than the other. Without getting into the particulars, usually a type 1 error is thought of as being less catastrophic, because at the very least, you can quantify a type 1 error. The p-value, we said it represents a probability. The p-value is the probability of making a type 1 error. Okay, so in this case, if our p-value was 3%, that would mean that we expect the null hypothesis, but we got something so far away from what we expected that our conclusion is it would only be a 3% chance of this happening due to chance variation alone. Because 3% is pretty rare, we reject that null hypothesis, accept the alternative that it's not chance variation, that there's actually something going on, that there's actually a relationship here. But 3% is still a quantifiable amount. Okay, 3% still happens. Okay, 97% of the time it doesn't, but 3% of the time it does. So the probability of making this type 1 error is 3%. A type 2 error cannot be quantified. A type 2 error would mean that the alternative hypothesis is true, but you did not have a p-value that was low enough, so you believe that the null hypothesis is true. Okay? Again, the number of the error is the hypothesis that is actually true. So if you had a p-value of something like 0.10, 10%, you would fail to reject the null hypothesis. You believe the null is true, but if the alternative is actually true, that evidence is out there, but you didn't see it in your sample to reject the null hypothesis. So therefore, this would be a type 2 error. Again, this is not quantifiable. Okay, the p-value, that number that you have, in this case 10%, that doesn't really mean anything in terms of the likelihood of that. So um, that's why this type 2 error is thought of as being more dangerous, because there's more of an unknown component. You don't know how likely it is that you made this type 2 error. Okay, so let's kind of look back at this chart right here now. Okay, so on the left column, okay, it has the decision, both in the courtroom analogy, the medical test, healthy and diseased, and in a statistical sense. Do not reject the null hypothesis, or you accept the alternative hypothesis. Okay, and then in the right here, we have the true nature of what happened. And now, again, this is usually unbeknownst to you. That's why you're performing this test. Yeah? But for example, if the decision was to not reject the null hypothesis, you believe that the null is true, and the null hypothesis is actually true, well, that is correct. But if you did not reject the null hypothesis, and really the alternative should be accepted, then that is a type 2 error. Okay? The undeserved freedom in the courtroom example, it's a false negative in the medical test. Coming down here below, if you choose to accept the alternative hypothesis, okay, so you believe that or you have the p-value less than 0.05, you reject the null, accept the alternative hypothesis, but if the null hypothesis is actually true, that is a type 1 error. Okay? Again, courtroom, that's the undeserved punishment, that's the false positive for a medical test. Okay? And if you accept the alternative and the alternative is actually true, that is the correct answer. Okay? Again, I find the most simple way to look at this is thinking the number of the error is the hypothesis that is actually true. However, your test told you to do the other thing. Okay? There's always a possibility of error, and at the very least, you need to acknowledge that. You're not saying that you made a mistake in the calculation. That's not why an error happens. You did everything by the book. Okay? It's just that nothing is certain, so you need to acknowledge what happened, what could be wrong if an error exists. Okay? There's another little meme that kind of shows you what the type 1 and the type 2 error would be. Okay, type 1 error, all right? You have accepted the alternative hypothesis, but really the null hypothesis is true, so that would be like this doctor telling this man that he's pregnant. Okay, obviously that doesn't make any sense in that case. Type 2 error would be saying this doctor telling this woman who is quite obviously expecting that she's not pregnant. Okay, if you have the null hypothesis of not being pregnant and the alternative hypothesis of being pregnant. So lastly, this is kind of like what I talked about on the previous slide, probabilities associated with errors. We can only specify the conditional probability of making a type 1 error, given that the null hypothesis is true. Okay, that is what the p-value is, and compared to that level of significance, typically 0.05. If the null hypothesis is true, the probability of making a type 1 error is equal to the level of significance, usually 0.05. If the null hypothesis is not true, a type 1 error cannot be made. Again, only one of these two types of error is possible based off the decision you made. A type 2 error is made if the alternative hypothesis is true, but you fail to choose it. Okay? This is the one that we said is unquantifiable. That p-value no longer represents the probability of that type 1 or of that error happening. Okay, that only represents the probability of a type 1 error if that's the conclusion that you make. So our last slide here, sometimes you'll hear the power of a test referenced. The power of a test is the probability of making the correct decision when the alternative hypothesis is true. If the population value falls close to the value specified in the null hypothesis, then it is difficult to get enough evidence from the sample to conclusively choose the alternative hypothesis. Basically, this is saying that if you're looking at that level of significance of 0.05, is your p-value that you get like 0.4, or mess that up, is your p-value 0.049, okay, where you're very, very close to that 0.05 and it's just barely under it, okay, that would have weak power because it's pretty close to that maximum value to reject the null hypothesis. Yeah. Or if you're talking about like the example we saw yesterday where you're 16 standard deviations away from the center of the curve and you have a p-value that's like 0.0000 or some really small value in scientific notation, less than 0.05. Now you're pretty sure that like this is definitely the right decision. Okay, the power of the test is there. So it's not just like a yes or no, black and white type of answer. Um, there is some consideration made here for how close you are to that level of significance, typically that 0.05 value. When you're rejecting the null hypothesis and deciding whether to reject it, consider the consequences of the two potential errors. Okay, this is important, especially if the conclusions that you're making have a lot of implications, a lot of serious implications. Okay, if this is a medical test where if you make the wrong decision, a lot of people are going to be affected in a possibly catastrophic manner. Okay, you want to be very careful with that. Maybe that 0.05 level of significance isn't good enough, and instead you want to change it to be like 0.01, or sometimes you'll even see 0.001, and it needs to be less than that in order for you to reject the null hypothesis. Okay, so those are the types of considerations that you're making. You don't just want to necessarily go with a blind level of significance of 0.05.